discussing Rhino. If you didn't have a chance to see our presentation during the Appsilon Shiny Conference, Rhino is a new package released by us specifically to help you building your applications. And so the idea being that this is kind of like a templating application, but we'll bring on Kamil in just a second to kind of talk more. We're going to have a section where we're going to go through for about 40 minutes through the code live. And then we'll have time for questions at the end. I'll be here to moderate the questions. So if anything comes through during the live coding exercise that you're interested in, we'll actually be able to stop Kamil and kind of dive into those questions. But if you have any sort of larger questions in general, please save that for the end, and we'll have plenty of time to discuss that. So without further ado, let me bring on Kamil. And Kamil, would you like to introduce yourself really quickly?
Yeah, thanks, Ian. It's nice to be here. My name is Kamil. I'm a full stack engineer at Appsilon. I've been working here for 2 years now. Being full stack means that I'm working across different technologies, sometimes projects which are completely unrelated to R and Shiny, sometimes strictly doing R Shiny. In terms of Rhino, it's a project that has a long history in Appsilon. Actually, it's one of the first things that I was involved in actually an earlier version of the project. You might have heard a bit of its history during our conference because, as I said, this project has a long history. And for past 3 months, I've been leading the project of actually building a package from all our experiences that we had so far. And we presented it at the conference 2 weeks ago, and today I will be trying to show you a kind of deep dive into what working with Rhino looks like. Yeah. So I think we can actually get started right away.
Okay, fantastic. Let me go ahead and share your screen.
So with a word of further introduction, I will be doing a kind of presentation leaf coding style. I do have everything that I will be coding prepared already, so it's kind of scripted. It's like a bit too much to do without mistakes. So in some cases, I might be just copy pasting a few snippets of code. But I think this style of presentation will be just a very efficient way to tell you about Rhino. And here I have Visual Studio open. This is what I use for coding in my daily work. This is, again, related. I'm not using RStudio usually. Sometimes I do, but I often work in other languages, and Visual Studio Code works better for me. And this is what I will be using today as well. So I'm going to start from scratch and build a simple application. It will be a Rhino application. It will be somewhat based on the tutorial that we have on our webpage. And first thing I'm going to do is to initialize this application. So I have terminal open here. Let's just go to R. And I'm starting with a basically empty directory. I just have git ignore here. It's a Git repository. It will be useful for me just like to take a look at the code if I need to. But otherwise, we are starting from scratch. And what I'm going to do to start a new application is called Rhino init function. With no arguments in this directory, what we will get is a full project structure of a Rhino application with a bunch of various files that we will be editing and adding to the structure along the way. So once I have app initialized, I'm going to do one thing. I only need it once now. I'm going to restart my R session because Rhino depends on some code in our profile here. And the easiest way to get this loaded is just to restart the R session. I won't need to do that again. So before we move on, I can just, I will be trying to do it in a way that actually I would do it if I was working with Rhino. So I will be also using Git and committing changes along the way. I think it will also be a good way to review what changed in the given step. So right now, I'm going to commit everything that we have here is the full structure of a Rhino application. And let's just a simple commit like that, and that's it. So during my presentation, I encourage you to ask questions on the chat. As Ian mentioned, he will be monitoring the chat, and he might choose some questions to ask me because I want to focus on the coding itself. I won't be able to look at it. But if there is something related to what I'm showing right now, feel free to ask. I think it's best to address it right away instead of leaving it at the end. I will still try to leave some time for general questions at the end of the presentation, but we will see how it goes, how much time I need exactly. All right, so we have a fresh application. First thing that I think we might want to do is to try to run it, and we do it by just calling shiny run app function. We start with an application that does nothing really, it just says hello on a blank screen, and that's it. So what I'm going to do is I'm going to create an application that can analyze the data set that we have available in Rhino. This is in this data set, we can see how the population of 5 species of rhinos, so that's how many species of rhinos there are, changed over time since, I think, 1800 something. And we are going to create a simple application that just shows a table with the data and also a chart with plots of the population over time, and do some other stuff around this. To some extent, it will be a toy example. The application needs to be sufficiently simple so that we can finish it in this single session. I mostly want to use it as a way to show you all the features of Rhino, basically. So we're done with the first step of initializing. So next thing I'm going to do is to add some R dependencies that I will need in my application. So I opened this dependencies R file. You can see a comment here which tells you why it's necessary. This is where you need to add all your dependencies that you want to use in your project. And in this case, I will want just a few. So first of all, I will want React table, which we will use to display raw data. We will also use eCharts for R to display the chart. I will need 2 pretty common libraries for just like data handling and transformations, replier and tidier. And lastly, HTML widgets. It will be needed just for a single small snippet of code. And it's also a good place to mention that HTML widgets is actually already a dependency of Rhino, but you should still declare everything that you use directly in this file. This helps in the long run to ensure that it's easy to see what are the dependencies of your project. It's always a good idea to keep this kind of list sorted, so that's what I'm doing here. Now that we've edited this file, second step to getting the dependencies into our project is to install them using renv. So I'm going to go to our terminal, and I'll just use this snippet, renv install, and get all the packages that I just added at once here. In the future, we might have a function that will do these things for you. So I'm editing dependencies R, I'm installing the dependencies, and lastly, I need to do a snapshot. So this should be connected. This might be connected into a single step. In the future, right now, we need to do this manually. By the way, you can read about this kind of recipes in our documentation. It's quite extensive. We do have, for example, an article which tells you exactly how to add, update, and remove dependencies. So I have everything installed and log file written. I can commit with changes now, so we can review it. We edited the dependencies R to explicitly list the dependencies we need. we installed them and took a snapshot to update the exact versions that we downloaded in our log file. So I'm just going to add this and commit everything. All right. So let's move on to actual coding. I will start with a simple table that will display the data that I mentioned. So to do that, I'm going to go to our application structure, and under app logic, I will create a new file, and I will call it just Rhinos R. So this will be where I'll be putting all my logic in this simple example. In real case, you will probably have various files here, for example, API, database, or like however you choose to structure your code to suit your project. In this case, to keep things simple, I will have just this single file. And maybe a word of explanation. So Rhino comes with this logic and view directories. This is where you should write your R code. And you might wonder why we have this split to logic and view. So it will become clearer as I'm coding now, but the basic idea is that view is basically a description of your user interface and a way to define it using Shiny. Everything that strictly needs Shiny, like the UI interface building functions, reactivity, and such, all such code belongs to view. Anything that can be expressed without Shiny belongs to logic. Under logic, I will try to implement actually the majority of the code that I have here, and I will try to avoid Shiny functionalities. This makes the code more testable, more reusable. In particular, avoiding reactivity really helps to make things testable. And you'll see that in a moment. So in this new directory, new file, I'm going to start coding. All right. So first of all, I'm going to kind of simulate what you would expect in an actual Shiny application that needs to get its data from somewhere. So in this case, it will be a simulation. I'm just using a static data set that is available as part of our package. But in real life, you could imagine a function here which would connect to API or to a database to actually fetch the data, and maybe to have a different data set for each user that connects and such. So this is slightly artificial here, but I think it will be useful to showcase how we suggest you to approach this logic and view division. Of course, we like the whole Rhino framework is heavily based on box. You're expected to make use of it in all your files to explicitly import everything you need. In this case, I just used Rhino. Just a small note here. Normally, after importing Rhino like this, I would access the objects from it using $sign. In this case, I will need to use double colon because it's a data set, and box, as of the current version available, CRAN, does not support getting data sets imported using box use. So this is just a kind of workaround for something that will change in box in a future version. You can imagine that we have a $sign here. So I have this simple function, and I'm going to mark it as exported. Second thing that I'm going to define in this simple module, another exported function, will be actually the definition of my table. And it will take data as an argument. And basically, I will use React table to display it. I can start very simple, just pass data to React table. Again, I need to import it to make use of it. So in this case, I will use this style of importing to import just this single function. And before I actually plug it into our application, I can already play around with this module and test what I have written here. I can go to my R terminal. With the box use, I can import the module that I just defined. And I can see what's inside. So we have these two functions. I have fetch data that I just defined. I call it. What we see is the simple data set, year, population, species. This is all we get in this data set, just 60 rows. And I have also this function table, which I can now run with the data that I just fetched. And this is what we get. A very simple React table that just displays the data frame that I just showed you. So I'd like to, this will be part of my application, but before even I define a module and plug it into the application, I can already see it and play with it. And that's what I'm going to do, actually. This is not how I want to view my data. First of all, I would like to see for each year 5 columns with a number of species of each column. Because right now you can see that we have this kind of style of listing this data that is not very convenient to browse. To do that, I'm going to use a function from tidyr, or tidyr, not sure how to pronounce that, called pivot wider. So just like to avoid a little bit of typing. Let me paste the snippet. So with this simple change, I can now reload my box module using box reload function and try to run to see this table again. And we now have something that is more readable. For each year, we can see how many rhinos of each species there were. Of course, the data is not complete, so we have some blanks here. Another thing that I'd like to fix is the year column. I'd like to sort by year. This would make it much easier to view. So I'm going to deploy here. And I will just arrange by year. So last test. Oh, this looks good. So we have the logic defined here already. Now we can plug it into our application. So what I'm going to do is I will go to my view directory, and here I will create a new file that will basically be responsible for displaying this table that I just defined. I will just simply call it table R. In this file, we need some standard structure for a box plus shiny module. So using box, I'm going to import two things that you will always need, a module server and an S function. And inside, we'll need to define two exported functions. UI, which will be a function of ID, and we also need server, which will also be a function of ID. The UI, in general, will always need this namespace function. In the server, we need to actually use the module server function to plug into the machinery of Shiny and how it handles modules. And now we can, this is a basic structure that you will always see. If you are working with RStudio, you can use an add-in to generate this automatically. But it's also simple to write this by hand or copy from the file. So in this module, I'm going to plug in the table that we just created. So first of all, let's import the module where we have the data and the table defined. Second, let's add the necessary imports here. So I will need reactable output and render reactable function for the server. And this module will be very simple. As I said, to some extent, it will be a toy example. I'm just going to have UI which consists of a simple output that will render the table. And on the server, I'm just going to render it. And here I'm going to plug in the functions defined in logic. So I'm going to use the table function and pass data to it. So I need the data as well. I will make it a reactive and initialize it with this fetch data function. I also need to add an import here, of course. And this should be good. A word of comment. So this might be a little bit weird what I'm doing here. So as I said, we are using static data, but for some reason, I'm adding it under a reactive and then passing that reactive. But as I said, you can imagine that actually this fetch data does something more important here. For example, connects to a database. And imagine that it happens for each user separately, that data is different for various users. In that case, you will need some kind of reactive or maybe a reactive value here that will hold it and be able to pass it into the module. And this is how I'm going to do it. As you can see, the server function is now very lean. The majority of the logic is defined in the logic. Using plain functions, which I just call here, I call it fetch data plain function and load it into a reactive. And then I unwrap that reactive and again pass plain data into the table function that I defined in this module. So the last thing that we need to do before we can see this in action is to actually plug in this module into our application. So we will need to go to the main R file, which is the top level module, the entry point to Rhino application, and add the module UI and server here. So to do that, first of all, we need to import the module that we just defined. We can get rid of some of the code here. We won't need this placeholder code. We can replace these parts. And all we need to do is to just plug in the UI and server of our new module. We should be good to go. Let's go to the terminal, try to run the application, and hopefully it works. We just have a simple application that displays the table that we saw a moment ago without actually running a Shiny application. But now it's within a Shiny application, and we will be expanding on that. So this is it for this step. We can add another commit. To review what happened, we created a new file called logic rhinos, where we defined fetch data function and table function, which can be used to display a table with the fetch data. We also created a table R file under view, which is the module which is responsible for displaying the table, and we plugged in everything into our main R file. So I can just commit everything now. And we're clean to continue. All right. Next thing that I'd like to do in my application is add a simple chart to display the same information. So I'm going to go back to my Rhinos module in logic. And this is where I will also define a function responsible for generating chart. It will be an exported function. again, taking the same type of data, I will want to display basically for each species, we have 5 of them, a line which shows how its population of the given species was changing year by year. So to do that, first of all, I will want to use dplyr to group my data by species. And now I will use eCharts to actually draw the chart. Again, to save me some typing, I'll just paste a snippet here. So what we have, basically a chart that we are plotting against year. We draw population lines like for each species we have grouped here. We'll be drawing the population, how it was changing year by year. We also set the range for x-axis so that it covers the range that we actually have in the data here. And we enable tooltips so that we can view exactly what was the population at any given point. Of course, we also need to add eCharts to our imports here. And again, before we actually plug it into the application, we can see how it works. So I can reload the Rhino module again. I have the chart function now available. I pass data to it. It will launch this thing for me. Cool, this is what I wanted. We have 5 species, and we can see how their population was changing over time for each of them. I will now plug it into our application. So again, I will be creating a box plus Shiny module to do that. So first of all, we go to View and create a new file. I will call it simply chart.r. I will just reuse the structure that we have here, because as I said, this is something that you will always need, and just get rid of the pieces that will change. And here I will define a simple module, again, a bit of a toy example, but something that will be responsible for displaying the chart that we just defined. So I will need, again, very similar to the table, 2 functions. eCharts output and eCharts render function. The UI will be simply an output. And on the server, we are just going to render it.
Hey, Kamil, really quickly, we have a question coming in from Annie Yu saying, would you be able to use Box to load modules from another folder and not in the project folder? For example, if we are loading functions that are commonly used across projects?
Good question. So in general, yes, it's possible, but I'm not sure if that's actually what you want to do. So there is something, I think, if we take a look. There is something called box path, and this is something that you can set to basically anything you want, and this is where Box will look for the files whenever you use Box use. And in principle, you could modify Box path to include a directory where you have your own modules outside of the project, and you could import from there. But I think it will be quite problematic in the long run, because as you are working with a single project, you will be depending on some files and the interface of those external files, which will be probably tracked, if tracked at all, completely separately. So if you are like modifying the functions that you want to be reusing across the project, you kind of need to keep the version of that in sync with what you are using in your project. And the proper way to do that, or okay, the proper way, I guess the best way to do that is to have a R package, basically. And that's what I would recommend, not just having a directory where you put your files, because in the future, like you'll change something in that common directory, and it will break one of the projects that depends on it. But if you actually have an R package with proper versioning and such, this won't touch you, because you will have renv in your project, which will install the exact version that you need per project. So you want to counter this kind of issues. So yeah, it's possible, but in my opinion, not recommended. So I hope I answered the question. Let me, and thanks for asking. Let me go back to the project here. So we are working on rendering the chart here. So I'm just going to use the functions that we defined in this logic module here to render the chart. So again, I'm using the chart function that we just defined and pass data to it. Now, where do I take data from? So in the previous module, in table module, what we did, we just got the data here. But I don't want to do this again. As I said, imagine that we are fetching this from some database. It's a costly operation. We only want to do this once. So I will need to actually reuse the data that I have here. And for that, I need some refactoring. So what I'm going to do is actually get the data as a reactive argument to my server function. And I'm just going to use it here like this. And the same will happen with the table module. Instead of having the data fetched here, I will get this as an argument. And now I will open my main R file. And here, this is where I'm going to fetch the data and pass it to the module as needed. So I also need to do a few additional changes. So in the table module, I don't need this reactive function anymore. In main R, I will need this logic/Rhinos module, which I'm now using for this fetch data function. And this was just refactoring. We have defined a chart module, but we have not plugged it in. We can test if the application works now. It's always a good idea to keep testing along the way, because things might break, and the longer you go, the more difficult it is to fix that. So right now I can see that I'm missing reactive function. It will be easy to fix. I forgot to add it in my main R file. Let's do that. After restarting, we can see that application works again. So last step, we are still working to add a chart to our application. To do that, we defined a box+shiny module. I need to plug it in to our main R file, just like I did with the table. So let's do just that. Also keep it sorted. Again, need to add the UI and server. Organized in this order. And this should be good. Let's try to run the application. I think I forgot to add a comma here. And we're good. We now have both the chart and the table. All right. Or maybe on second thought, let's keep the table at the front, so data first, and then the chart. All right, so this is it. We have just like, let's check after the simple change still works. It does. This is it. We have now both the table and the chart. This is what I wanted to show in this step. We can commit changes. To review what happened, we added some stuff to our Rhinos under logic, a function to generate a chart. We also created a Shiny plus box module to actually display the chart. and we added it to our main R module. We also touched the table module because we wanted to do some refactoring to use the data that we fetched so that it's only fetched once. So I can now commit everything. Let's continue. So before we move on to adding some additional features, I'd like to do a little bit of refactoring, you could say, and also show you another reason why we like Box. It's a package with quite a few functionalities, and I just want to showcase one of them. You might have noticed that we have these init R files, both in Vue and Logic. This is the mechanics of Box, and I think the best way to explain it will be just to show you how it works. So I'm going to this Vue init R file, and here I'm going to use Box to import the two modules that I have in Vue, the table and the chart. Just give me a moment. So I'm going to import AppView chart and AppView table. And what I'm going to do here is I'm going to re-export it by applying the export statement to this Box use statement. And this might seem like a weird thing to do, but the way init files work is that anything defined as exported file function or object in this file can be imported directly from AppView. And this is some nice trick that can simplify your imports. Now I can, instead of having multiple lines importing everything from AppView and repeating this all the time, I can just do something like this. And this should work exactly as it worked just a moment ago. This should be just refactoring. So let's try to rerun the application. And hopefully it launched without errors and works exactly as it did. So Box has more features. I won't be showcasing all of them. And this is just a small teaser for what you can do with it. Again, to review, we just edited the init R file to add some exports, re-exports, and then use that to simplify the imports in our main R file. All right. So just give me a moment. Please give me a brief moment to plug in my wireless mouse. It seems that it has run out of battery, unfortunately.
Always happens on a live coding.
Exactly. All right. Good to go. OK, what I'd like to show you next is how to work with JavaScript in Rhino. And for that, I will use also a very simple example. Let's see what our application looks like now. In this chart here, we have years at the bottom, but for some reason, we have commas here. And I'd like to get rid of them. This can be done quite easily. We just need to go to our to the place where we have this chart defined. And I will need to use a formatter argument here. Give me a moment. So this formatter argument here takes a JavaScript function that will be used to format the labels on the x-axis. So To define that function, I will need JS function, just like to mark code as JavaScript from HTML widgets. But instead of writing it here directly, I'm going to show you how you can work with JavaScript in Rhino in general. So if you take a look at this project structure again, we have this JS directory and index.js file here. And this is where you can write your JavaScript code using all the newest features of JavaScript that are available. The code here is processed with Babel and Webpack to produce a Minified file and to support basically any new feature that you can have in JavaScript. And it also does some things to keep your code a little bit more organized. To show you what I mean, I'm going to define a format year function here. It will just take a value and return it as a string. So you could do it other ways as well. This is just like to show you how this works. I want to use this function to format the value of the labels on the x-axis. To do that, I will need to mark this function as exported explicitly. And here I will be able to use it just like this. But I also need to add an app.prefix. This helps to keep your code organized, does not pollute the global namespace in the browser. So everything that is defined in index.js and marked as exported will be available under app. Before I can actually use it, I also need to do one more thing. I need to build the JavaScript into a Minified file. We have the Rhino build.js function for that. What this does, it automatically installs using Yarn node packages for me. This is what runs underneath to actually handle what I just described. It builds the Minified file and automatically includes it in the application. So I don't need to do anything more. I can now run my application again. And we can take a look at the labels. I hope you can see it, that the commas are now not there and it's formatted as we wanted. So it's also a good place to mention that for working with Rhino, we also have the lint JavaScript function. So this is in addition to having all the latest features supported and also being able to structure your code into files and to import them and such. We also have a linter that can be used to improve the quality of your JavaScript code. And just like to show you what it can do for you, if you call this lint.js function, it will tell me, for example, that a semicolon is missing in the file. I just deleted it. We also have a fix argument that can automatically fix many errors. It can very easily add semicolons for you. Not everything can be fixed automatically, but many errors can. So this is it for this step. Again, let's commit. To review, we created a function in our index.js for formatting year labels. And we use that function in our code responsible for generating the chart. And lastly, you can see that we used Rhino build.js, and this generated a file for us. By default, it's Git tracked. This allows you, for example, for very simple deployments in RStudio Connect, so-called Git-based deployments. You can argue whether you want Minified and build files in your Git repository. We believe in many cases it's reasonable and really simplifies some things. So that's why Rhino works this way by default. All right. Before I move on, a quick comment. I can already see that I'm taking more time than I was hoping to. So I think we'll kind of finish on time, hopefully. So if you have questions, please ask them, because I don't think there will be much time in the end for general discussion. So Ian, if you see anything like related to what I'm doing, like feel free to interrupt me. I think it's best if I address it now.
Yeah, actually, Kamil, we do have one great question coming from Eric Nance. where he says, so the Rhino documentations recommend not using the Sass R package as the engine for build JS and build Sass. Other than the R package using a depreciated implementation, are there any other technical reasons why you recommend that?
I think that's the main reason. The implementation used by the R package Sass is deprecated, and the one that you can use in Rhino with Node is the latest implementation available. Actually, I think there's some ongoing work in the R package Sass to update it to also use the state-of-the-art implementation. I think besides that, there is no reason not to use that. However, if you are already using Node, you get all these other tools that I will be still presenting, like linters for both Sass and JavaScript, bundlers for both, and also end-to-end tests. So if you're already committing to that, it makes sense to just go with the Node approach, in my opinion. But other than that, no. If you want to use the R package, feel free to do that. You can actually do that by going to Rhino YAML in your project directory and changing this node to R. You can read about that in the documentation. I will just mention it, won't be showing that exactly. Okay, if any other questions, feel free to interrupt me. I will now show you another feature of Rhino, and that is styling. Yeah, exactly. I will show you how to use basically Sass in your application. So I'm going to start with actually going to my main R file. I basically want to make the application look slightly nicer. Right now, if we take a look at this, this is just like two widgets, one below the other. I want to add a title here, put this side by side, add some shading around both the table and the chart, just like to give it some structure. And I'm going to use a bit of Sass for this. I will start in main R. First of all, let me add a title. This will be very simple. I'm just going to use title panel from Shiny and just put it here. And let's call it this. And now we have a simple title, nothing else changed. I want to give it some structure, as I said, and for that, I'm going to use some Sass and also some helper functions. So this is another good thing to mention. In your modules in the view directory, you are not limited to just defining this UI and server. Feel free to define any helper functions. They don't need to be exported if it's just used by the single module. And in this case, I'm just going to have two simple helper functions, grid and card. This will be just wrappers which apply div and a proper class that I will define in a moment using Sass. Before I do that, I will use these helper functions to add structure to my page. So I will display the UIs of my two modules in a grid. And I'm also going to wrap them in cards. This will add some shading and styling, just like this. Right now, nothing should change yet. We are just adding some structure. Of course, we need to import everything that is necessary. The application still looks the same. Besides that, let's go to the Sass part. So we have the styles main SCSS file, and this is where you can write your Sas code. And I'm going to start with just, first of all, defining the grid class. It will just make me two columns for me with some spacing in between, simple as that. I'm also going to define this card class that I use, and let's start with just adding some padding. And let's see how it looks now. It's also an opportunity to show you, again, how to use Sass in Rhino. So I'm going to launch another terminal here and open an R terminal. And we have this Rhino build Sass function. And I'm going to use this watch through argument. I will keep this open, and what this will do for me is it will watch for any changes in this main SCSS file and recompile it every time I build it. This will enable me to iterate very quickly on my application. I just can run it now. We can take a look. You can see that we already have some changes. We have 2 columns here, and the table and the chart appear side by side. So let's continue working on our Sass file. What I'd like to do is to, I think, add some border here, because everything is too close to the border of the page. So let's just add some styling for body, 20 pixel margin. I can just refresh it. The file was recompiled instantly. You can see that the border was added. And I would like to just add some visual differentiation for these 2 components. So what I'm going to do is I'll add a simple mix in here that can be used to add a shadow. This is one of the reasons why you might want to use Sass instead of plain CSS. It has many cool features like mixins, for example. And what I can do now is I can include it just in any class that I'm defining very simply to apply shadow to it. After refreshing, we can see this effect. And this is it for this step. Let's commit the changes that we made. Again, we added some structure and title in our main R file using CSS classes. We defined those classes using Sass in our main SCSS file. And lastly, we built it into, again, a file that is automatically included and placed under app-static CSS, similar to JavaScript. All right. So here it's a good moment to show you another cool feature of Rhino that you get when working with Sass. Similar to the lint.js function, we have the lint Sass function. If we run it, we will get just our code style, information about errors that we have in the code. Here, I get complaints about mixin and include. This is something that we are going to fix soon. This is actually something that I noticed when I was preparing for this workshop. This is because the linter is not configured to accept these mixins, but we're not actually at loss. Rhino is quite flexible here. We can define our own rules, and I can do that very simply. I'm going to create a file under styles, call it styling rc.json, and this is where I can define custom rules for my Sass linter. So I won't be going into details of how this works. I just want to show you that it does. If you have different needs than what Rhino provides by default, you can just create such a file and customize the linter to your needs. And if we run it now, you can see that the errors are no longer there. This is because we configured it so that Sass linter understands the mixing and include rules. So just a simple change here. So I think the last thing that I'd like to show you is how to work with tests and with unit tests and end-to-end tests in Rhino. I have just 5 minutes, so I'm going to skip a little bit here. What I will do is I will just I'll jump into the project with another module added. And that module added, I think it's best if I just show you on the running application. So it wouldn't be very difficult here to add such a module. It's just another module which displays checkboxes and allows you to add some filtering. So this is, again, pretty standard R work. So that's why I think it's safe if we skip over it. I need this so that we can write some unit tests and end-to-end tests, just like to show you how this works in Rhino. So assume that we went over adding this additional filters column. And now what we can do is we can add a unit test and an end-to-end test for that. So just to show you what changed in the Rhino's logic module, we have this species list of Rhino species, and we have this filter species function. It's very simple. You probably wouldn't write it normally like this, but it's good enough to show you how to write unit tests in Rhino. The process is actually pretty standard. We have this test the directory. It comes with a simple test that we actually won't need because it was for the sample code that comes after initializing Rhino. Instead, I'm going to rename this file into logic Rhinos. I'm just using the path of the file that I want to test with slashes changed to dashes. And I will need this function. Here I will want to include this. And I'm going to just add a simple test. And not to write this by hand, because we're out of time. You write tests in Rhino just like you would normally do. The difference maybe is that you use box as well in your tests. And this simple test just has a data frame with two species of Rhino, A, B, A. It has some logic that is able to test it kind of independently from the data structure. You could see previously that we actually did not have an ID column, but that's fine. This function accepts it. Now to run such tests, we have a function called Rhino test R. After running it, we can see that there is some problem. I'm not sure actually. I guess we don't need this test anymore. We have a test that passes. Thing to mention here, this is run automatically for you in continuous integration checks. And I just want to quickly show you what it can look like. This is what you get after pushing the repository to GitHub. You will see that we automatically run all the tests for you. In particular, we are linting your R code, linting JavaScript, Sas, running R unit tests and end-to-end tests for you. If something fails, you can take a look right away and see what was wrong. You can also run it locally to debug it. All right, I have a question now, Jan. Is it okay if I take 5 minutes more to complete and show the end-to-end tests, or should we better finish now?
I think it would be very important to show that aspect, and I hope everybody on the call today has time for 5 more minutes.
Absolutely. So let's go with it. I'm sorry for taking more time than we had planned. Leaf coding actually takes quite a bit of time. Okay, without further ado, let's just commit the changes that we introduced here. So we added a unit test. what I want to show you in the end is how to add end-to-end tests. So end-to-end tests is something that can run your application, interact with it, and verify how it works. And this is very powerful. It sometimes takes time to write such a test, but it can really be used to verify that everything works from beginning to end. And to write end-to-end tests, we use this tests Cypress directory. We have the app.spec.js file here that I'm going to use to write a simple end-to-end test. And right now, this test simply opens the application and then does nothing. So this checks that the application runs. I can actually show you how this works. So I will be running tests using the test end-to-end function. And I will be using this interactive switch. This will, instead of running everything and just showing me a final report, show me a nice window where I can see each test that I have defined, and I can run it automatically to see how it runs. So we start with a blank test, so it just opens the application and does nothing more, so the test passed. But I want to actually make it do something useful. What I'm going to do is I'm going to uncheck all these boxes and verify that something better than an error appears here. So yeah, right now we have an error in red marks, which does not look very nice. Say that we just noticed it, so we will write an end-to-end test to verify that this bug appears, and then we will try to fix this bug. So to write our end-to-end test, I'm going to expand this function. Maybe also let's add a nicer description here. And in this function, I'm going to, first of all, find the element that contains the filters. And the way to do that is basically to use the browser and the inspect feature. So what I can see here, if I take a look, I guess the fonts might be quite small to see what's exactly happening. But by looking at the HTML structure, I can, for example, see that this whole box has an ID app filter species. And I can just use that to find it in my test. So with this, I'm getting the div that contains all the checkboxes. And now I take all the inputs. So this is just a CSS selector that gets me all the checkboxes. And now with a function called each, I will be able to write simple test that clicks each checkbox for me. So once I do that, what I'd like to do is to verify that in the chart here, we have some nicer message that we have now. Right now, we get an error. So what I'm going to do is to try to, again, get that element. I will skip that. The ID looks like this. We actually need to get its parent to get to the div where the message will appear. And I can now assert that it contains some text. And I'm going to expect that it says select some species. This will be part of the message that I want instead of that ugly error. Let's try to run this now. Again, in interactive mode. The test should now fail because we will be expecting something that is not in the application. But let's just verify that if we wrote the test correctly. So what you can see, the application opened, all the checkboxes were unchecked, and now we waited for 5 seconds to see that select some species text appeared here. It did not, so the test failed. So now I'm going to actually implement error message so that this test does not fail any longer. So To do that, I'm going to go to my app view chart file, and I'm going to, again, use some standard Shiny functionality to add validation here. I will import validate function and basically add a single call to it here. So we need some braces to make this work. So this will check that the data, the number of rows in my data is non-zero. Otherwise, it will tell me to select some species to see the chart. Let's see how it works. If we run the application now, we need to add some additional import. If I check everything now, we can see that a nicer message appeared instead of the ugly red one. So let's see if our test can also verify that. Again, running in interactive mode. I can run the test, see it perform in front of my eyes, and now the test passed because the message that we wanted appeared. And this is it for this demo. I'm sorry that I went over time, but I'm happy that I was able to show you everything, so I think it was worthwhile. Thanks for asking questions along the way. I actually still have some time, so if it's fine for you, Ian, and if there are any other questions, I'm happy to answer them. But otherwise, the leaf coding part is over. It's still not all the features of Rhino. As you can see, it's hard to present everything in such a short amount of time, but I covered the majority and the most important ones for sure. You can learn more from our documentation. Right, so.
Okay, fantastic. Yeah, thank you so much for everything here, Kamil. I think I can speak for myself and hopefully not everybody, but I feel like I learned something here. We definitely had a couple questions come down the line. Some of them are highly specific, so I'll just start with that. We had one question from Eric Nance about using BSlib in our Rhino applications. Is there anything that would stop us from being able to use that in the full way we would in a, say, normal Shiny application?
Not at all. I'd say that BSlib is completely perpendicular to Rhino. You can use any package for styling, for widgets, for UI that you want. In particular, I could imagine just like going to our main R file where we have a Bootstrap page here and changing the theme to something else. This will work. You can simply add BSlib to your dependencies, import it here, and use it just fine. It should work without any issues.
Okay, fantastic. So we also had a question from Daraj about if you already have an existing application built in Golem, is it easy to transfer to Rhino? Is that going to be something that's going to take a lot of time, or are these structures kind of generally similar enough that we'll be able to do that easily?
Excellent question. This is something that we asked ourselves a lot, actually. When we, to give a bit of introduction, as I said, we had some prior work and projects before Rhino was created. And one of the things that we were thinking a lot about is how to port those projects that were our commercial projects and basically applications that we are doing that use those previous iterations of Rhino, you could say, into Rhino. And we also thought how it would be possible to migrate applications created using other technologies. For example, Golem. So we made some efforts to make that to make it possible. We have a migration guide in our documentation that explains the steps that you need to take. And I'd say that how much effort will be needed really depends on the particular application. I think in terms of Golem, it will be possible to, like, our guide has some, you could say, few steps that you can take, and you can stop at. You don't need to go full way before you can actually start using Rhino. It's possible to plug in an application which does not use box at all, for example. And I think you can use that to take a Golem application and plug it into Rhino pretty fast, but not everything will work, and not all features will be available. If you have a large application that you want to completely port to Rhino to use all the features, it will take some work, and I think the biggest obstacle will be actually making everything use box. Golem assumes a flat folder structure, file structure. Everything is just in one namespace, all the functions that you define. Box forces you to explicitly name all the dependencies, to import them, export them, and such. And it does take a while to move from this implicit flat structure to this explicit box structure. But I can say that I think it's totally worth it. We had some cases where we did exactly that. It's often hard to find time for such a thing in a commercial project, because there is, like, I'd say, little often reason to do that. There's, like, no immediate benefit from doing that. But actually, we found some bugs doing that, and we restructured applications into something more comprehensible. So I really think it was worth it. So back to the question, it is possible to port a Golem application to Rhino. We have a guide, a generic guide, not for Golem only, how to do this kind of migration in general. It will take effort. Depending on your application, it can be little to quite a lot. But it's not necessary to do everything at once. You can do it kind of step by step, and we hope to improve that in the future.
Okay, yeah, thank you so much for that. It seems like through some of the questions that we're getting is that Box might be new to a lot of people here. I've been using Box maybe for 6 months, and the main reason that I started using Box was because of the speed when you're using it, and Box not requiring you to reload a module every time you hit that Box function. But one thing, maybe for anybody who's using Box in a regular way, if you are doing that and you make a change in your Box module, you then need to run Box reload. Is there a way built into Rhino that it, like, clears this cache, or if people are constantly making changes, do they have to go in and do that reload for each file?
Thank you. Very good question. So yes, Rhino does some reloading. Just to give you a quick, to quickly show you what's happening. So this is something that I did not cover now, but Rhino comes with this app.r file that has just a single line that you should not edit. It just calls the Rhino app function, and this is where we plug in all the Rhino machinery, and we can do various configuration things. In particular, we configure Box and we purge its modules. So during this whole live coding, you could see that I was not restarting my R session at all, only at the very beginning to reload the whole project. But afterwards, I just kept rerunning Shiny run up, and it worked. And it worked because this function cleans up the cache for you. It's not perfect, though. Ideally, we would just keep the application running and modify the modules and refresh the page to see the changes. And actually, there is a possibility that this will be available in the future. There's some ongoing work in Box to provide hot reloading, and in particular to support it for Shiny. And there are also some, like, things around reloading that we noticed when working with Shiny that we are also going to kind of implement. So hopefully in the future, you will just open up the application, modify the code, and after refreshing the page in the browser, it will be working for you. Right now, you just need to close the application and run the Shiny run-up function again, and it will reload all the modules for you. No need to restart our session.
Okay, thanks for that explanation. And we have a couple other questions to get to, but I really wanted to very quickly mention this about when I've used Box in the past, and say I'm calling the dplyr package, what I would do is do dplyr open brackets .. close brackets, and that would load all of the dplyr functions. So for people who are looking at this and saying, do I really have to list every single function that I want to use from a particular package? Are you able to do the .. and use that in the same sort of way, or do we need to explicitly call all these?
Yeah, absolutely. I could do this. This is another feature of Box. This will just import all the names from dplyr package into this file, and then I could, wherever I use dplyr, I could just use it directly. So this is pretty much what you would get if you did something like library dplyr. Very similar in terms of how you work with it. In general, I would discourage you from doing that. However, it makes sense in some cases if you have like some module which heavily uses dplyr and not much else. It might be actually quite reasonable to import everything there, but this should not be the default way of importing things. It does, like importing everything name by name, or just like getting the module and then repeating its name wherever you need a function from it, comes with a cost. You actually need to update these imports each time, but it really helps maintainability in the long run in our experience. You avoid name clashes. You can immediately see what functions are being defined and which functions are being used. And in general, it's just a practice that you can see in many other modern languages. Oftentimes, your IDE will be managing the imports for you. I actually hope to see this for R in the future as well, so that it won't be a burden to do this manually, that the imports will be updated for you automatically. But yeah, right now we have this. So feel free to use whatever you prefer. If you really want to go ahead, use 3 dots and feel like you were using just library calls, but we encourage you to be explicit.
Thank you for elaborating on that, Kamil. One of the other questions that we got from Eric Nance is, are there plans to let users easily create modules via simple snippets like the golem add module function? Or and maybe that's a segue into another question of, what do you expect in terms of changes, improvements? What are the goals long-term for Rhino, if that's not too big of a question?
Yeah, it's kind of a big question, but I can give some thoughts on that. So what was the first part of the question again? Because you asked about long-term plans in the first part.
Yeah. I guess the first question was, are there plans to be able to easily add modules via snippets?
Right. Yes, we had a bit of discussion around that. It's possible. I'm not sure what will happen with that idea. I'd say that we kind of see the philosophy of Rhino a bit different here. We'd like to make it so simple and boilerplate less to add code that you actually don't need functions that create files for you. To make it so natural that you just write a file and it works for you. But I can see the possibility of having a function, for example, for adding new box plus shiny module. We will need to have more discussion around that and see if it fits into how we see Rhino. I'd say this is a feature that is just like, it's not a difficult thing to implement. It's more of a question of the philosophy of how we see Rhino and working with it. We don't necessarily want it to be like another, like use this, for example, package that is just used to insert snippets of code. Rather, we think of Rhino as a framework that you plug into and that helps you to avoid having to insert boilerplate into your code, into your project. So this is regarding this kind of functions. Regarding long-term plans, yes, that's quite a big question. We have a backlog of ideas, but I think I can give a glimpse into what we are thinking about. One of the things for sure is taking care of Node.js. We realize that it's inconvenient or sometimes impossible for many users to get it installed on your machine. And we are looking into ways for providing the same functionality that we have here without requiring you to have Node.js on your system. I'm not sure if that will be possible, but it would be wonderful if we could do that, and we are looking into that. We are thinking about adding features which will help you to track user adoption of your application and basically track what's happening with your application. I'll just leave it here. This is just a big feature that we would find very useful in our own work, and it's part of our Shiny manifesto. We will be looking into how to implement that exactly. Besides that, I think there are lots of things to polish. There are many things that work but could work better. For example, you just saw that the Sas linter required some reconfiguration to make it work. So we will be fixing this kind of things. This will be definitely a big focus now to polish everything that we see so far. And I think I'll stop here. We have many more ideas, but I won't be listing all of them.
Okay, yeah, thank you for that, Kamil. And yeah, my apologies on such a big question for such a short amount of time. One other question that we had that came down the line is, will a user be able to use the browser function as they would in a normal Shiny application when working with Rhino? And sorry to add another big question on that, but is there anything else that a normal Shiny developer in their normal workflow and normal things they do that sticks out in your mind that you won't be able to do in Rhino?
I'd say the biggest challenge, again, might be box. This really changes how your application is loaded and changes in some ways how you work with it. But otherwise, Rhino itself should not heavily impact debugging and related things. In particular, you should be able to use browser function. It should work for you. We are thinking about adding, okay, that's another of the features that we might consider, some kind of debug mode for Shiny that would help you to basically debug your application. One thing to mention here, for example, Rhino, I just did not have time to show it, but Rhino comes with a configuration for logger, which you can, in your application, use just by, for example, import Rhino and the log object from it. And now anywhere in your code, you can, for example, write log info and write something. The level can be set, the logging level can be set with the environment variable, and also in other ways. You can read about that in our documentation. So this is, for example, a feature that you wouldn't get by default in Shiny that is present in Rhino already. Otherwise, the things that you're used to should work, and hopefully we will add more features that will help in development itself.
Okay, fantastic. Thank you once again, Kamil. Well, I guess we've got to wrap it up here really soon, but one other question that was really sticking in my mind as I was trying to get a bunch of people from the pharma industry last week at the Fuse conference to use Rhino. Sometimes it's nearly impossible for somebody to be able to install an updated version of Node.js on their machine. To anybody who's in that situation, will they still be able to fully utilize Rhino? And maybe more specifically, are they still going to be able to use like this app.prefix when they're calling their JavaScript? Maybe that's a little too specific, but for those people, do you have anything to say?
Right, so you will be able to use Rhino, but unfortunately not fully. Some functionalities will not work. What you can do is you can still use Sas. Like there are workarounds for all of this, but some features do require Node. So for example, if you want to use Sas, what you will need to do is to go to Rhino YAML and change this configuration to R. And this will now use the R package, and you should be able to use it just like you used to. You won't be able to use the Sass and JavaScript linters. They are like directly implemented through Node.js. You also won't get end-to-end tests. They also rely on Node.js. You will still be able to write custom JavaScript. To include it, you can just put it into this static JS directory and include it in your project as you would normally do. However, regarding that app prefix, you won't get that because then that file won't be going through Webpack and Bubble as it does with Node. We are thinking about providing some alternative which works using R only, but right now it's not there. So if you don't want to use Node, you'll just need to use plain JavaScript, create a file, include it, and use it as you would normally do in a Shiny application. Otherwise, the features should work. Only the things that I mentioned will be the limitations. So linters for Sass and JS, the end-to-end tests, and you'll need some workarounds or changes for Sass and JavaScript coding. But you should still be able to use everything else.
Okay, fantastic. Thanks again, Kamil. Well, I think we are well over the amount of time we had originally slotted to this. So we'll go ahead and let you go, Kamil. Is there anything else that you'd like to say other than goodbye to the people who tuned in today?
I think I'd just like to say it was a pleasure to present, and thanks for all the questions. It's really nice to answer them, to hear that there's some interest in Rhino. I'd like to maybe say that Rhino is the first time that we are showing to the world how we approach in Appsilon building Shiny applications. And it's a project with a long history, but Rhino itself is quite young. So we will still be working heavily to improve it, to fix the issues that we see. And the fact that you are interested and you are asking questions and you are using it and like participating in discussions is really important to us, because this will allow us to really improve the package. So yeah, I hope that this will continue and we'll get more users, hopefully more this kind of webinars in the future. So thank you so much. It was a pleasure to take part in this.
Yes, it was. Thanks again, Kamil. All right, well, we'll let you go. And lastly, everybody who attended today, thank you so much. We really appreciate you coming. I hope that you all were able to gain something of value. And in general, we hope that you took away the theme that Rhino we're at the beginning of this project. We're going to be building it. We're going to be continuing to add new features. And some of that is going to come down to the feedback that we get from you guys. So, if you feel the need to say something, please reach out to us on Twitter or any other method to get a hold of us. Please check out the GitHub documentation. And lastly, thank you guys once again. And we look forward to presenting more packages and talking more about Rhino with you guys in the future. All right. Bye-bye.